All right, welcome to This Explainer. So if you're a data scientist making the move into MLOps, you already know that production code is a whole different ballgame. Today, we're going to jump into a super important skill that really separates a simple notebook from a robust ML system: automated testing. Really, it's about how you build systems that you can actually trust. I mean, come on, we've all been there, right? Your script runs all the way through, no big red error messages, and you think, whew, okay, we're good. But, and this is the key question, just because it runs, does that mean it's correct? In these big complex data pipelines, tiny bugs can sneak in and, silently mess up your results for weeks before anyone even notices. So how do we stop that from happening? How do we build that safety net?
Well, that safety net, it's all about formal automated testing. So let's just dig into why this is such a big deal in MLOps. And look, this isn't just some box you have to tick for the software engineers. No, this is absolutely fundamental to making sure the stuff you build is reliable and trustworthy.
Okay, first up, we've got unit tests. Think of these as your first line of defense. Instead of trying to test the whole complicated system at once, you're just looking at one tiny piece, one building block at a time. Like, let's say you have a data normalization function. Does it really scale a feature from 0 to 1 like it's supposed to? A unit test confirms exactly that, and only that. It isolates that one little piece of logic.
All right, next up, regression tests. So imagine this. You just pushed a brilliant improvement to your feature engineering code. Awesome, right? Well, regression tests are the safety net that makes sure your brilliant change didn't, accidentally break something else further down the line. They're what stop you from taking 2 steps forward and 1 giant step back. And finally, we have end-to-end tests. These zoom all the way out to see the big picture. So after you've checked all the little pieces with unit tests and made sure you haven't broken anything with regression tests, these tests make sure the entire workflow actually works together. For MLOps, this means you're simulating the whole shebang, from raw data coming in all the way through pre-processing right to a final model prediction. It confirms that all the parts are playing nicely together.
Okay, so this is where it gets really, really critical for ML folks. See, a regression in machine learning isn't always a big, obvious crash. A lot of the time, it's a quiet, subtle drop in your model's accuracy. A good test suite will catch that, and that gives you the confidence to refactor your code, to make it better, faster, cleaner, without being terrified you're going to break something. And what's really cool is your tests end up becoming a kind of living documentation, showing anyone on your team exactly what each part of the code is supposed to do.
This slide, I love this because it really gets at a crucial mindset shift. I mean, we've all littered our code with print statements to figure out what's going on. And hey, they work for a quick fix. But that's all they are: temporary. Automated tests, on the other hand, they're a permanent, reliable system that's always on guard, validating your logic every single time the code changes, forever.
Okay, so if we agree we need this permanent validation system, what tool do we use to build it? Now, Python does have a testing module built right in, but we're going to focus on something a bit more modern, way more powerful, and honestly, just a lot more fun to use: Pytest.
So why Pytest? Well, we recommend it because it just hits that perfect sweet spot. It's so simple, you can write your first test in like 2 minutes, but it's also powerful enough to handle a super sophisticated test suite for a massive production-grade ML application. And here's the real beauty of it. It's just simple. There's no weird boilerplate code, no complicated classes you have to remember to inherit from. Seriously, if you can write a Python function, you can write a test. You just name your function starting with test underscore, and then use a plain old assert statement. That's it. It's so clean, so readable, and just incredibly effective.
Okay, so now that we see how simple a single test is, let's talk about how we build that up into a proper, organized testing suite, because a few simple rules here can make a world of difference.
All right, these 3 steps are pretty much the key to keeping things seen. First, put all your tests in their own tests/directory. Easy. Second, always start your test files and your test functions with test underscore. That's how Pytest automatically finds them. No configuration needed. And third, inside your test, try to think given, when, then. It makes them so much easier to read. Given this setup data, when I perform this action, then I assert this is the result. Simple, clear, and super readable. Now, it's really important to remember this. Testing isn't just about the happy path. It's not just for when things go right. Good code needs to fail in predictable ways when you give it bad input. You have to test for that. And that's where pytest.raises comes in. You use it to say, hey, I expect this piece of code to throw a value error, and the test passes only if it does.
Okay, so as you start writing more and more tests, you're going to notice something. You're going to start repeating yourself a lot, especially with the setup code. To fix that, it's time to level up with one of Pytest's absolute best features, fixtures.
So what's a fixture? The best way to think about it is like a reusable setup for your tests. So instead of loading the exact same dataset at the top of 10 different tests or initializing the same model over and over, you write one fixture to do it one time. This keeps your test code itself super clean and focused on just one thing, validating the behavior.
So at the end of the day, fixtures are a game changer. They help you write tests that are cleaner, faster, and way easier to maintain. They just get rid of all that repetitive setup junk. And you can define them in one central file, a contest.py, and then they're available to your entire project. You can even get fancy and control how often they run. Like maybe you have an expensive setup that you only want to run once for the entire testing session. A fixture can do that. Okay, so here's a common problem. How do you test a single function with a bunch of different inputs? You want to test the normal cases, but also the weird edge cases. Empty data, bad data, that kind of thing. You really don't want to just copy and paste the same test over and over again, right? That would be a nightmare to maintain.
Well, the solution is just beautiful. It's a decorator called parametrize. You write the logic for your test just one time. Then you use this decorator to feed it a whole list of different inputs and what you expect the output to be. Pytest is smart enough to then run your test separately for every single one of those scenarios. It's an incredibly efficient way to cover dozens of cases with just a few lines of code.
All right, last section. Let's wrap up with some best practices that really turn testing from just a task you have to do into a professional habit, a habit that becomes the foundation of your project's quality.
So one number you're going to hear thrown around a lot is code coverage. It's basically a percentage that tells you how much of your actual application code is being touched or run by your tests. Now, aiming for 100% isn't always realistic or even useful, but a really solid target to shoot for is at least 80%. Look, high coverage doesn't guarantee your code is perfect, but low coverage definitely tells you there are dark corners of your codebase that have never been tested, so it's a really useful health metric.
So this checklist right here, this is more than just about writing code. This is about building a culture of quality on your team. Keep your tests clean, readable, and make sure they can run on their own. Use fixtures for all your setup stuff. Test the weird edge cases, not just the easy, happy path. Keep them fast so people actually run them. And most important of all, automate the whole thing in a CI/CD pipeline. That way, your safety net is always, always on. So look, as you make that leap from building models in a Jupyter notebook to engineering real production systems, just remember this. A solid automated test suite, it's not a chore. It's not a burden. It's the safety net that gives you the confidence to innovate, to refactor your code, and to build really powerful, complex things without being afraid it's all going to crumble. So the real question is, once you have that safety net in place, what are you going to build?